Collections provide the possibility to group elements that somehow belong together, because they share a common topic, or you need them for a certain project, or any other reason. A user can create multiple collections in a portal, and there is of course a listing of all the collections available with the possibility to open up the detail page of every collection.
In this collection here, we see already that in one collection there can be data from many different data pools, and all the elements are then also grouped by these data pools with these tabs here and listed in the corresponding listing elements of the corresponding data pool. And since we are reusing the same listing elements here, we have again the possibility to change the view. We have the possibility to multi-select elements. We have the possibility to apply actions to a single element or multiple elements, like remove them from collections or add them to other collections, or just adding them to cards, downloading them, or these kind of things. And we also have the possibility to filter the assets or the elements of the collection by the configured filters. Then, of course, we also have the possibility to download all the elements from a collection with this download button here, and there we have the possibility to now download them by data pool and download them to a combined zip file. Another very important feature of collections is the sharing feature, which allows us to share the collection with a different user. There we can decide if we want to just allow reading, or we also want to allow that the user can edit the collection. And if we allow the other users to edit the collection, it's a great tool for collaboration, where every user can add, remove items from the collection, and so we can really collaborate on the collections. Once the translation jobs are created, they will run through a certain translation workflow, which is of course depending a bit from the actual translation service we are using, but most likely it will look somehow similar to this one here, where we at some point submit the job to the translation service. They will then translate it and send it back to us, and we will receive it either partially or completely, and then at some point we will process it and apply the data back to the data objects. This workflow can be observed in the translation jobs dashboard, where we see all the jobs and also the state of each of these jobs, and there we also could apply the actions, so do all the workflow steps manually, but most likely this will be executed fully automatic by just running commands in the background. Actually, we know this command already. It's this translation provider interface bundle jobs command, where we have these different options we can use for processing all the jobs in the different states. And normally we will just set up certain cron jobs that then will process all the different jobs. But let's for now quickly go through this command manually. So we submit the job, then we get some remote ID, see that the job is now submitted. We receive the data back from the translation service and import all the data back to our system. Actually, there we have then a couple of debugging possibilities, like we have the possibility to see exactly what data we did export to the translation service. It's just a JSON in this case, and also what we got back from them. And we also have this data overview tab, where we see all the data that is now sent back. So we see this English text here, and then we have the different translations here. Actually, we're using here a dummy translation service, so they're just doing some strange characters here, and this is their translation there. And yeah, then the last step is to apply the data to the data objects. As mentioned before, the typical way for the integration will be the full automatic process of this workflow. That means we set up all the cron jobs, and this is done fully automatic, and the dashboard here is just for observing and not for manually going through the steps of the workflow. And then this translation workflow will be embedded in a bigger workflow of the Pimcore workflow engine, where we have some places for requesting the translation and then also some places for reviewing the translations if even wanted and possible in terms of knowledge and resources.
Hi, and welcome to another session of Pimcore Insights. In this session, we'll learn about Pimcore Data Hub plugin, how to set it up, and use it. First, let's see what is Data Hub and its main goals. Data Hub is a data delivery and consumption platform. It provides easy to configure data layer on top of Pimcore data, be it objects, assets, and documents, which can be used to expose data to external systems or consume data from external systems. The aim of Data Hub platform is to consolidate different input-output channels like GraphQL, CSV XLS adapters, enhanced REST APIs, and many more in future to provide single source of truth for all data needs. So let's talk about one of the most popular channel here, which is GraphQL. GraphQL is a query language for APIs. It allows you to define the structure of the data required, and the same structure of the data is returned from the API server, which is Data Hub in this case. When querying Data Hub, you will exactly get what you need, since GraphQL returns predictable data. As a result, you can create fast, stable, and reliable apps. With GraphQL, you can get complete data in a single request as opposed to REST APIs, which requires multiple requests to serve the same data.
Hello and welcome to this session of Pimcore Insights. This time it's all about the CI Hub integration. The CI Hub integration brings the integration of Pimcore with desktop publishing program to the next level and allows accessing data that is managed within Pimcore directly in Adobe and Microsoft products. The challenge here is that we need to prepare the multidimensional and often really complex data model of Pimcore for the integration into CI Hub. That means we need to define which entities, which data attributes, and which assets should be available in CI Hub. And since Data Hub does a similar thing, we decided to integrate the CI Hub integration into Data Hub and created an additional CI Hub adapter. This is how the configuration looks like.
CI Hub configurations can be added to the Data Hub as any other configuration and also follow the typical Data Hub configuration way. That means we can activate an endpoint, we can specify a description, and then we have all the settings for the detailed configuration. First of all, we have there the schema definition, which defines exactly what data entities and data attributes should be available at CI Hub. There we can select multiple different data object classes and specify the data model and the attributes for each of these classes. Again, in the same way as we do it for the grid configuration for the data objects. That means selecting all the data attributes that we want to have available in CI Hub, and also we have the possibility to add certain operators like extractors, like formatters, like transformers to extract more complex data out of the Pimcore data model and make it available for CI Hub. In addition to the data object classes, we also have the possibility to activate the assets for CI Hub. That means that CI Hub is allowed to navigate through the asset tree and also search for assets. And then we also can specify if we want to deliver the original images and or if we want to deliver additional thumbnails to CI Hub. Once the schema is defined, we again define the workspaces, which define then exactly what data elements should be available at CI Hub. This follows again the typical Pimcore way of defining workspaces. That means just adding folders which we want to have included in the CI Hub endpoint. At this point we also can explicitly exclude certain folders, which allows us to really exclude certain elements and make them not available at CI Hub. This is sometimes really practical, especially when you define different CI Hub endpoints, for example, for different creative agencies, and so you can really define in a very fine-grained way which elements should be available and which not. Then we also can define nice names for all the labels that are available in the CI Hub endpoint. So we have all the attributes from the asset metadata and also from the data objects, where we can define nice looking labels that are really understandable for the users of the CI Hub. And in addition to the labels here, we also can specify what attributes should be allowed to be filtered on CI Hub side. So there we can activate all the filters that make sense for the CI Hub. And last but not least, we also can add an API key again for this endpoint, which then need to be configured at CI Hub side to be able to access to this endpoint. And that's about it. Save this endpoint and Pimcore is ready for CI Hub.
So far for the Pimcore side of the integration. For the CI Hub side, either have a look at the video from our Inspire conference or directly visit the webpage of CI Hub.
Hello, I'm William Johnson, Solution Engineer from Products Hub, and I'm here to show you a few highlights of our platform. As you can see, I'm in the platform Products Hub, which is a software as a service, so you access it through your browser. You don't need to install or maintain anything on your site. I'm currently in the Pimcore account in the syndication project for Europe, Middle East, Africa. And the project is just like a folder where you can store as many sites as you want. So in this case, this folder has two sites, one for Germany syndication and UK syndication. And each one of these sites can ingest, aggregate, transform, and export data to as many export channels as you want. So we're going to go into the UK site to just see a bit more details how this looks like. I get into my site, I have access to my dashboard where I can see how many items were imported, how many were exported, and to what channels the feeds were exported to. Now the first part we're going to look at is data sources. So where is the data coming from that's coming into this Products Hub site? If I go here, as you can see, we have a dedicated import from Pimcore where we can get all the data we need to get from them. We could also aggregate more data from another subset or hierarchy level of Pimcore data. In terms of exports, as you'll be able to see, we can have as many exports as we want. We're not limited. So if I go down, you see in this case, I have 5 different exports, and it's very easy for me by clicking here in this button to add as many exports as I want to this site. Now let's take a look at the data itself. If I go in data view, I have an idea of what my data looks like as it comes into and transits through the Products Hub platform. So here you can see I have the data at the import level. That means as it comes in from my Pimcore bin. And the data is going to flow through different stages in the Products Hub platform. The intermediate stage, which is a bit like a golden record hosted on Products Hub, where we can already split or merge or improve or modify data. And then we're going to have a chance to see and change data for each and every one of the available exports that we set up for this site. So if I go in Google Merchant Center, for example, I'll see the data as it's prepared for this export, but not just see it. If I go in this little drop down and click on readiness, I also have a view of whether my data is ready for Google Merchant Center. So I click here, I can see the data is not quite ready to go out, which might lead to poorer performances or the feed being rejected in some cases, and this might even lead to penalties depending on the exports you'll be working with. So if I click here on description, I see everything is not fine, and the sidebar opens, and we see on the right, these are analyzer tests, which are hosted on Products Hub and which tell me whether the data is ready to go out or not. And here I can see the feed contains some HTML tags, some uppercase fields, and also maybe some consecutive white spaces that I need to remove. So I'm just going to click here on these little suggestions, which actually add rules that are going to change the data. And as you can see, the platform is going to refresh, and we have now a view of the data as it has been modified by the rules I just applied. This was the data before, this was the data after, and you can see the incidence on the readiness. So we are now 100% ready to be exported for this field. For example, you see the P HTML tag has been removed. Let's just close this and go in a tiny bit more detail. If I go to price, I see the price is not ready. Again, I click here. I can see these tests appear, and I see that I need to have the currency attached to the price. So again, I want to really highlight all these tests are hosted on the Products Hub platform. You don't need to go and look at the rules that Google Merchant Center wants you to respect. You don't need to look into all these documentation and type code and manage all this yourself. This is all presented to you in a very clear, easy to use way in Products Hub, and you have these rules to make the data comply. So now let's see how we can correct this price. If I go in this little pencil, I'm going to have a chance to change the data for this field. So if I go in price, I click here, you're going to have a chance to see the little rules that we use to modify data. So I have already one prepared here. I'm just going to activate it and save. And here again, the platform is going to refresh and present the data as it's changed. In essence, this rule is just appending the currency column to the price. And here you see again how the data is changed from this to this, and how it's gone from 50% to 100% readiness for the export. So that's how easy it is for you to change, to view your data, import it from Pimcore, change it and make it ready for any of your export channels in a few clicks. No coding required. So you can be sure that your feed will behave and perform as best as possible on each and every export channel. And again, these tests are only for this export, and we can do the same for all of the 1,500 plus export channels that we host. Well, that's it for me. Thanks for your attention. Goodbye.
Hello and welcome to this session of Pimcore Insights. This time it's all about the Pimcore Experience Portals. The major goal of any experience portal is to visualize information and make this information available to a broad audience and many different target groups. And this is also the goal we are aiming for with the Pimcore Experience Portals. Create portals just by configuration, define exactly what content should be available in what portal, and so make the content that is managed within Pimcore accessible to a broad audience. That's what the Pimcore Experience Portals are all about.
So let's see how we do this, and just log into our demo portal. And there we jump right into a dashboard page, which can deal as first entry page for all the information that is visualized in the portal. The dashboard page here can be configured with so-called Pimcore document area bricks, and so you really can compose this dashboard page and use certain text elements, certain teaser elements. You even can use certain statistics elements and configure a dashboard page that really fits your needs. All the information that is available in the portal is accessible also via the main navigation, where we see all different data entities that we are providing in this portal, and we also call these entities data pools. A data pool defines exactly what data should be available, can be really defined in a very fine-grained way, and each portal can have multiple of these data pools. Let's start with collecting the items for translation, and there are two ways for collecting the items, a manual way and a more automatic one. The manual way is quite simple. Just use the context menu in the Pimcore backend and click Request Translation. There are a couple of settings for the translation job, like the due date, like a name for the translation job, defining the source language. If the element has children, we also can include all the children, and if there are multiple levels of children, we can restrict it to the first level, so just direct children and not the whole tree. And then last but not least, we need to define the target language or target languages. Click OK, and we have requested the translation. This also is possible with whole folders. There we have also now this include children activated here, and we also see an item count for all the translation items that will be created if we tick this. Same is also possible for a selection in the grid. So also there we can request a translation, and it is also possible to request translations directly from the object grid. To make this work properly, we need some configurations that need to be set up during the installation of the bundle and are described here in the documentation. And these are a couple of Symfony configurations there, like the default provider, which is a Symfony service and defines to which translation provider we want to send the translations that we are requesting in the backend. Then we can specify the notification recipients, which are recipients that get notifications with the Pimcore notification service. And then last but not least, we also can define the allowed languages, which can be a subset of all the languages available in the Pimcore system. The automatic way for collecting items for translation requires a bit more configuration, and this configuration is described here in this automatic change detection section of the documentation, because this automatic way is based on a change detection of relevant data. For setting up, we have to do 2 steps. The first step is to defining a so-called data changed handler. And this data changed handler is responsible for checking if relevant data has checked. And it's basically a service that needs to implement this data changed handler interface. And the framework already ships with a default implementation, but you also can use your own custom implementation if you need some special functionality there. If you use the default implementation, then this default implementation can be configured with a certain set of attributes. First of all, we can define the source language, we can define the target languages, we can define the translation provider where we want to send the translation to, and last but not least, we also can define the allowed classes the change handler should listen for. It is also possible to configure multiple data changed handler. So for example, different data changed handler for different object classes that need to be translated in different target languages, or where we want to send the translations to different translations provider. Once we have set up the data changed handlers, then we also need to configure that these data changed handler are triggered automatically every time, for example, a data object is saved. And for that, we need to set up event listeners that listen for these update events and trigger the data changed handlers. And for that, there is also already a default implementation available from the framework. And what we need to do is just configure this as a service and register it as an event listener. And as soon as this is set up, then we just need to open up data objects that are listened for example, here this news object, and let's just add here some text, save this, and now in the background the data changed handler is activated and will listen for data changes. To pack all these items that we required for translation to a translation job, doesn't matter if we did this manually or with the automatic change detection, there needs to be a command executed that normally runs in the background, and this is this translations provider interface bundle jobs command. And there are a couple of options we have available here, and the relevant option for this step right now for creating the actual translation jobs is this create job from changed items. So this one needs to be executed, and then all the items that we requested for translations are really packed into translation jobs. And as soon as this is done, we have this translation jobs available also in our translation jobs queue, where we see now our 2 jobs we have created. The first one based on this manual data object we have changed, where we have this event here, and then the second job is based on this automatic change detection, where we have this news object in our translation job. Of course, one translation job also can have multiple items included. It depends, of course, on how many we requested and how many changes were made. Another very central feature of each portal is a search functionality. And so we have also, of course, there a global search, which is a full text search on all the data that is in all the data pools with some kind of autocomplete feature with auto suggest, where we can directly jump into detailed page of certain elements, or we also have a search result page where we see all the results again grouped by the different data pools. And again, for each data pool, we have the possibility to use all the features that the data pool provides, like selecting items, applying certain actions to the elements, switching the view to the more list-like view, and also applying additional filters where we can further narrow down our search result. Or in addition, we also can just add an additional search term here and so narrow down the search. We also can save the searches for later use. So there is somewhere a menu in the profile menu where we list all the saved searches. We can reopen them, and we also can share them again with other users.
Hello and welcome to this session of Pimcore Insights. This time it's all about the integration of translation services into Pimcore. Actually, there are a couple of ways of how to integrate the translation service into Pimcore. The most basic one would be to manually export the data with the xlif export and re-import it back with the xlif import. The Translation Provider Interfaces bundle provides a more automatic way of the integration for translation services, like for example for translations.com, for which it is also officially certified. The integration supports data objects out of the box. Assets and documents are also supported but need some additional integration work. The basic idea is to somehow collect all the items that need to be translated into so-called translation jobs, and then these translation jobs follow a certain translation workflow of the translation provider, and in the end all the data is imported back into the Pimcore system. All the things we saw so far can be set up just by configuration, no coding needed. And the best thing about this, the configuration isn't even particularly complicated. So let's just create a new portal and set up the most important things.
And for that we switch into Pimcore backend and just use a setup wizard that we are providing, and for example create a new portal for events. We specify a domain. We specify the available languages. This is something I forgot to mention before. Each portal, of course, can be configured in multiple languages, so it's possible to switch languages. Then we define some logo here and some background image for the login page. And then we can start configuring data pools. Let's start maybe with a data object data pool for the events. We just use some nice icon here. Select the class definition of the data objects we want to visualize in this data pool. Let's say we want to use the event page and specify a detail page layout, which we use there, which is the portal layout. Then we can specify if we want to activate the folder navigation and the tag navigation in the listing. We do that not for now. And then we define available downloads for thumbnails and available download formats for the structured data. Let's just add a couple there. And that's already it about for the most important configuration. Maybe we just add an additional data pool for assets now. We see a bit more data too. Again, choose an icon. In this case, we activate now the navigation options. Again, define the configuration for downloads, for the thumbnails, for the shortcut buttons, for download formats here. So let's just select a couple of things there. And so we can configure step by step all the data pools we want to have available in the portal. And then once we're finished with configuring the data pools, we can say create portal, and Pimcore creates us the portal. The actual portal itself is just a site within Pimcore, and the configuration of the portal is nothing more than Pimcore documents with certain configuration options here. So there we see all the things we configured in the wizard, and when we open up the tree, we see a document structure with all the data pools we configured, and when we open up the data pool pages here, we see additional configuration options we have for each data pool. But actually we don't need to configure anything more. We just now can open this in the front end, log in into the portal, and there we see we have already our event data pool with all the events available, with the detail pages where we see all the information that we configured here. And of course, we also have this asset data pool available that we configured, where we see all the asset information and all the assets that are available in this data pool. Speaking of sharing, there is one more possibility for sharing, which is, we call it public share. And this public share allows to share elements with users that don't have a login to the portal. We can share collections, and we also can public share just single elements or a selection of elements. So we can there just select a couple of elements and everywhere have this share button here, where we then can specify a couple of settings for this public share, like a name, an expiry date when the share should be expired. Then we have the possibility to define this that we want to require the user accepting certain terms before downloading the elements, only for the magazine, whatever. And then again we can configure the download options we want to provide for the users of the share. So we can decide, okay, we want to allow the metadata download, for example, or we specify the thumbnail of the asset itself that should be downloadable. Then we create the share, we get a link, and with this link then a user can access all the shared information. Again, we have the grid, we have the possibility to open up the detail page, and we also have the possibility to download the information either with the single items or in a collective zip file. Let's just jump into the first data pool, which is called asset material and is a data pool that provides asset data. Each data pool provides a listing page, as we see it here, where we see all the available elements of this data pool, with a view where we have a big preview image and information about the element name. And we also have the possibility to change the view here to a more table-like view, where we have only a small preview image and the possibility to configure certain attributes out of system attributes or metadata attributes to visualize additional information there. Navigation within such a data pool can be done either by folders, like we have it here of the Pimcore folders, and also via tags, which are also the Pimcore available tags. And in addition to the navigation options, we also have the possibility to configure filters that allow us to filter the elements based on system data and also based on any metadata. Each element has a couple of actions that are available for this element. Of course, we have a detail page available, and we also have the possibility to select multiple items directly in this listing here. As soon as we select these items, we see a selection bar here in the bottom where we see what items we have selected, and also there we have the possibility to apply certain actions to all the selected items. One of the most important actions that a portal should provide is maybe the download action, and let's just already jump into the download action. And when we download elements, we don't just download the assets themselves, we have a couple of settings that we can configure before we download. First of all, we configure for the asset itself whether we want to download the original or whether we want to download a predefined thumbnail, which is already reduced in size, or we even can allow the definition of custom thumbnails where we allow to define width, height, format, and quality. And in addition to the asset configuration, we also have the possibility to define in which form we want to download the metadata. And as soon as we click download, the download gets prepared in the background, a zip file is generated and packed together, and as soon as this is finished, we can download the zip file and get the data to our PC locally. Besides the actual download, we also have the possibility to add the elements to a cart, a download cart. Again, we have the same settings we have also for the download itself. And here a download cart is a collection of elements that I can put together and then download in one go together later on. Download cart, we have all the elements we added, of course. We have the possibility to configure the configuration, the download configuration, and of course change it. And then we have the possibility to download all the items together in one zip file. Back to the asset grid. There are a couple of more actions we can discuss right there. So maybe let's just use this add to collection there. The enterprise portals also have a feature that is called collection, where we can collect different items from different data pools together that somehow belong together because they have the same topic or they are needed for a certain project, for example, for a magazine article or whatsoever. So we just can collect these items and put them together. One user can have multiple collections and we can select here from an existing collection, or we also can just create a collection right away, a new one in this place here. More on collections a bit later on. Let's just have a look also at the detail page, which gives us an overview of the asset with a very brief preview image where we also have the possibility to make it full size and even zoom into it. We have an area where we have some general information that can be configured again and shows information out of the asset metadata. We have some file description information here. We have the possibility to see and edit all the tags of the asset, so we can there assign additional tags to the asset. And if a workflow is configured on the asset, we also see the current state of the workflow and the possible actions that we can apply to the workflow. Then we have there some shortcut buttons for downloading the asset, where we can configure which format we want to download, and then we really just can directly download the asset itself and not have to select the download settings as we saw before. In addition to the overview tab, we also have a metadata tab where we see all the metadata of the asset, where we not just see the metadata and all the different tabs and information there, we also can change the metadata, where we can add text there or even can add additional metadata collections, where we can just add additional metadata and save the changes, of course, to the asset. Then we have embedded metadata visible, which is the metadata information that is embedded directly into the image file, like ITPC and XMP and EXIF data. And this is just visualized here at this place. And last but not least, we also have all the versions available for the asset. And so we can see a list of versions, and if we have more versions than one version, we even can compare this. With one version, it doesn't make sense to compare it. Then we also have a couple of action buttons here again, Most of them we know already, like this add to collection button or add to cart, download. Then we have also the possibility to move the asset to a different folder and a couple of additional actions. Let's go back to the grid, and there we have one important thing left that we need to discuss, and this one is uploading new asset data. Actually, there are a couple of possibilities to upload new asset data. First of which is to really configure a certain folder in our folder hierarchy where we allow to add and upload additional assets. Or the other possibility is that we define a central upload folder, which is one dedicated folder where all the uploads take place. And once we are in a folder that allows us to upload assets, we can just drag and drop them or use this upload button here, and then we can select the files or upload assets from URLs or even upload a zip file which gets extracted then. The next step is to define certain information that we want to apply to all the assets, like for example assigning certain tags to the uploaded assets, or also assigning certain metadata information where we can add certain information. Then we also would have the possibility to change the file names of the uploaded files to a certain schema if we want to do this. Then the upload is done, the assets are uploaded and placed into the folder, and as soon as the upload is finished, there is some kind of an upload report where we see all the assets that were uploaded, where we have the possibility to open up the assets right away, and we also would see if anything went wrong there. Then when we open up the asset, we see of course also the metadata that got assigned to the asset. Speaking of metadata, the detail page is not the only place where we can change the metadata. We also have the possibility to batch edit metadata. So let's just, for example, add some additional assets to our selection, and then there we have this edit button which allows us to edit tags and also metadata information. So for example, we can change the license information here, apply the changes, and then the changes are applied in the background task, and as soon as it is finished we can reload the view and see the updated data here.
One of the great things about Pimcore is that we are not only able to manage assets but also structured data with the Pimcore data objects. And therefore it's quite obvious that portals that want to visualize all the information that is managed within Pimcore also need to be able to visualize data objects. The Pimcore Experience portals can do this by providing a special data pool type for the data objects.
And so a different data pool can, in this case for example, then contain data object data. And again, we have a listing there where we have again two different views. We have this table-like view with a small preview image with certain data attributes that are visualized directly in this table view. We also have this grid-like view where we have the big preview images with just the name of the data object. We also have the possibility for navigation based on the Pimcore folders. If tags are assigned to the data objects, we also have the possibility to navigate via the tags, and we also have the possibility to configure filters based on data attributes of the data objects, and so narrow down our selection here. Also, we have again all the different actions available on each element, and we also of course have again the possibility to select a couple of them, see the selection bar again with all the selected items, and apply certain actions to all of the selected elements. Let's maybe just open up a detail page. And the detail page now of the assets shows all the information that is available in the Pimcore backend. So it shows really all the data attributes. Of course, we can configure the layout of the detail page with using custom layouts. So we configure in the backend of Pimcore how the detail pages of these data objects should look like in the portal. And there we have actually all the possibilities to visualize localized fields, to visualize all the text attributes, also relation attributes. Even we have the possibility to link to other detail pages here if they are available in the portal. We of course have the possibility to visualize media information like images, again with the possibility to open up links to detail pages of the linked asset, and also all the other attributes. Actually all the core data types of Pimcore are supported for these detail pages, and so I really can present all the information that I manage within Pimcore. In addition to the data attributes themselves, we also have the versions available again, and if there are versions of a certain data object available, we have there the listing and also again the possibility to compare two versions with each other. Also, we have again the possibility with these action buttons here, like we have, for example, download possibilities, where we can configure again some download settings. First of all, we can decide how we want to download the structured data of the data object. So really define how we want to download all the data attributes. Again, we can choose from different formats here. And then in addition to the structured data, we also see a list of all the image relation or general asset relation data types of the data object, where we can then define if we want to download the linked assets, and we also can again configure certain format settings here for download the elements. And then again a zip file is packed and all the information is downloaded. Of course, we also can add data objects to the download card. So let's just also add it to a download card. And there we have now added our data object to the download card and can download it together with all the other elements that are in the download card. Last but not least, it's also important to know what's going on in the portal. So we need some kind of statistics, and for that we provide a set of predefined statistics that are shipped as document area bricks. That means we can include them in any document, in any dashboard, in any content page. And there we have things like data object types, like an overview of the asset types, like logins during the last time, downloads over the last time, or for example also most downloaded assets. We also then have the possibility to use a so-called statistics explorer, which allows us to really deep dive into all the data and do certain kind of data mining. There we can choose a data source, we can define certain rows and columns, set up pivot tables or normal listings, apply additional filters, certain field settings, create visualizations, like for example, let's just add a pie chart here. And so we can easily create reports that really allows us to deep dive into all the data that is available in the portal, and also allow us to save these reports and share it with other users.
Let's have a look at how to get started with the framework and how to work with the framework. To do so, let's switch back to our demo basic and set up a simple data model and install the e-commerce framework. I already prepared some data model classes, so I created a product category class with very simple, just a name attribute, and I also created a product class with a few more attributes, but still very simple, a name, a description, some other attribute, and a categories relation, which is of course a relation to the product category class. As mentioned already before, This data model is completely free, so you can set up whatever data model you need for your e-commerce use case and for your application. What I also did is that I just created a few data objects here in this product management folder. I created two categories and I also created two simple test products. So let's start with the e-commerce framework, and the first step of doing so is that we need to install the framework. We can either install it via the extension manager in Pimcore backend, or as an alternative, we also can install and enable it via the CLI commands of Pimcore with the bundle commands. Once the e-commerce framework is installed, there are a couple of things added. There are created a few database tables on the database, and also Pimcore created a couple of data object classes, which are especially for the orders, like the online shop order item, for the voucher management, like this voucher series and voucher token class, then for tax management, and also for the offer component of the e-commerce framework. If you don't need some of these classes, you easily can delete them. You don't need to just keep them here in order to set up the system working. So the first step for setting up or getting started the e-commerce framework is to set up a product index. And to do so, we already said that we use as a data model simple product objects and product category objects. But what we need to do is that we connect our product classes with the e-commerce framework, and also we need to connect our product category with the e-commerce framework. Let's start with the product category because this is the simpler one. And the only thing we have to do here is that we make sure that the product category is extending a certain e-commerce framework class. This framework class is of course also mentioned in our documentation, which is the abstract category, and we need to make sure that the abstract category is set here as parent PHP class. The second thing is to prepare our product class itself, and for preparing this product class there are actually two ways of doing so. In the end they just result in the same thing, that we need to make sure that the product class implements two interfaces, either the iIndexable interface and second the iCheckoutable interface. Which interface you need to implement depends a bit on which parts you want to use from the e-commerce framework. When you want to use the indexing part, then you need to implement the iIndexable interface. When you want to use all the cart and checkout functionality of the e-commerce framework, then you need to implement the iCheckoutable. There is also an abstract class available of the e-commerce framework. You can use that, but you don't necessarily need to use it. But yeah, what you need to make sure is that you implement these two interfaces. The abstract class can also be used to get some reference implementations of the methods that the interfaces define. But for now, let's really just start very simple and create a subclass of our product class that just implements this interface. To do so, let's go back to our IDE. Say we define a data model, which is, for example, my product. This, of course, needs to extend the product class that we created and implement this iIndexable interface. And now we just add all the methods that we need to implement here. And yeah, let's just go from top to bottom and implement all the methods. First defines whether a product should be included or not. Let's just make that dependable of the published state of our product. price system name is relevant for the whole price system specifications. For now, let's just use a default price system here. Then whether a product is active or not, we also make dependable of the published state of our product. The index type we make the same as the normal type, so being variant or object, and the parent ID of our object we return also our parent ID. So now we implemented our interface, and now we need to make sure that Pimcore is using our implementation instead of the default one. This can be achieved with the class mapping functionality of Pimcore. We discussed this already in different courses. We just need to specify the class override here in the Pimcore config tree. Actually, there are already a few samples. We just can copy and modify for our needs. We want to use our my product Pimcore model data object product, and we want to use the my product instead. After that, we need to make sure that we reload our Symfony container, and then we should set up for the indexing. For setting up the indexing, let's use an additional YML configuration file where we now configure all the e-commerce framework configuration, and as it is a Symfony config configuration, it's just the same pattern. So we use the Pimcore e-commerce framework configuration tree, and there we have several options, like for example the index service. And within this index service we can configure different tenants and now we use an academy tenant, for example, and for this academy tenant we now configure all the necessary options that we need for our indexing. Actually, there are two. One option is that we need to define which attributes we want to use. These attributes actually are the attributes that are extracted out of the Pimcore data object model and put into the index. Right now we make it really simple. We just configure, for example, the name, and there we need to define the type of the attribute in our product index, which should be, for example, just a variable character of the length 255. What options you have here in defining the index and the index attributes, you can find all in our documentation. There are several options of defining the types, defining where to get the data out of the data objects, how to modify the data, how to interpret the data, and so you have lots of different possibilities to modify also the data that should go into the index before it actually goes into the index. The second important option here is that you need to define a so-called config ID, which is a service ID of an implementation of the index configuration. The index configuration is a normal PHP class that specifies certain configuration options of the product index itself, and it also defines which kind of product index you are creating. So we're using different configuration options for example, MySQL product index or Elasticsearch product index. Let's just create a simple folder here and define a configuration, myconfig, for example. Namespace is already correct, and in this case we can extend from existing configurations like for example for MySQL, we just extend from the default MySQL configuration. And when we have a look at this implementation here, we see that there are several things specified, like the table names for normal product index, for all the relations of the product index, and a couple of other configuration things. And what we need to specify in our own implementation now is that we make sure that we use our own table names. So let's just override these two methods, get table name, academy index, for example, and another one, public function get relation table name, which is academy index relations, for example. That's already it. What we need to do now is that we define a service of our configuration. So we need to register it in the Symfony container. So let's just create a service section here where we specify our config. And at this point, it is important that we define a certain parent, and the parent is actually the abstract configuration of the e-commerce framework. So this is this class here. This is necessary to tell Symfony and the Symfony container how to set up this configuration service correctly and to define all things properly here. And now what we need to do is to add the configuration ID to our tenant configuration within the index service. And now we are telling the system that it needs to use this configuration with this index type for our Academy product index. And this is it already in terms of setting up the product index, of configuring it. What we need to do now is to make sure that our e-commerce configuration file is also loaded. So let's just import it into config.yml, and then the next step is to go to the console and bootstrap the product index, which means to create all the necessary data tables on the database. Bootstrapping the index is done with the bootstrap command of the e-commerce framework, which is called e-commerce index service bootstrap. And there are actually two options which are available, and we need now the first one, which is create or update index structure. And with this command, Pimcore creates all the necessary tables on the database. And when we now go to the database here and see if the tables are created, let's just make that a bit smaller, then we see already there are our two tables, Academy Index, Academy Index Relations. And when we open up the Academy Index table, we see that there are a couple of system columns, and the last column is the name column of our configuration. And now when we go back to our Pimcore and just, for example, save our data objects, our product data objects, then it should be automatically added to our product index. And when we now go back to our index table, reload this table, then we see that it's not in there. And when we now go back to our Pimcore backend and just save the product objects once more, then these products should be added automatically to our product index. Let's just go back to our product table, reload it, and then we see here already that our two products are now added to the product index. Yeah, and the last step would be now to get the data out of the product index again. And for that, I prepared already a controller action, which just returns products as a JSON. And there we now add a product list and prepare the data for this JSON response and get the data out of the product index. And let's just create a product list. For that, we use our e-commerce factory, get the index service, and from the index service, we want to get a product list for a certain tenant, which is the Academy tenant. Now for the product list, we could specify things like limit, like order key, like conditions, like category, all these kind of things. For now, let's just leave that empty and just get all the products that are in our product list and just loop for each over this product list and prepare the JSON data. Like for example, we just want to get the ID here and the name, product name. There we need an S. And now we get all the products out of our index and prepare a reduced JSON object for them. And when we go back to our browser, reload the action, we see that we now have a list of products here. Let's, for example, just filter for a category, which, for example, category 2. Just get the product list here, set category. There is a category object expected. So let's just get our product category, get by ID 55, for example. And now we would expect that the product list is reduced and only one product is returned anymore, because only one product has the category with the ID 55 assigned. So this sample shows you already how to get started with the e-commerce framework, how to set up a product index, and also how to use the product list and work with the data that is stored within the product index.
Besides the installation and the setup of the customer class, there are a couple of additional configuration options that allow you to configure the customer management framework, and these are described here in the configuration chapter of the CMF. There are two big areas. First of all, there are services that allow you to modify and extend the behavior of the customer management framework. We'll cover them in the upcoming courses when we need additional services. And in addition to the services, there is this configuration tree, which allows you to configure certain aspects of the customer management framework. This configuration tree is commented and documented directly inline, so it should be pretty much self-explaining, and we are going to just highlight a couple of features which are the most important. First of all, there is an option to specify a custom Pimcore class for the customer class. So this option allows you to rename or to set a different name for the customer class. By default, it's customer, but you could set any other class name here if you want to. Then we have some newsletter settings or newsletter export settings. We have some encryption settings here, and then we have settings that are in the context of saving the customer data objects. First of all, there is the customer provider, which allows you to configure a certain path in the data object tree where the customer objects should be located at. And in addition to that, there is a naming scheme that can be configured and optionally enabled in the customer save manager. And once this is enabled, every time a customer object is saved, then the naming scheme is applied to the customer data objects, and so you have a unique naming scheme for all the customer data objects. And then there is the customer save validator, which allows you to configure certain checks when a customer data object is saved. For example, checks for required fields. The default configuration in this case says that either the email address or the first and last name need to be set in order to be able to save a customer. Then we have settings for the segment manager, especially where the segments should be located by default in the data object tree. And then we have settings for the customer list, which is this additional customer view, which allows you to search and filter for customer and export them. And the exporters can be configured at this place here. You can specify which exporters should be available and which properties they should export. And in addition to the exporters, we also can configure the filters here, especially the filter fields, which attributes should be used for these filter fields, which is especially handy for the main search field, which is the full text search at the bottom, at the top of the customer view, and there you can specify in which fields this full text search should search. And last but not least, there are a couple of settings for the customer duplicates service. We'll have a look at them in detail in the later courses. Once the installation is done successfully, there's one thing left that needs to be done by the developer, and this is setting up and configuring the customer class itself. The customer management framework uses the Pimcore data objects for managing customer data. And since we want to use the full power of the Pimcore data objects and don't want to restrict the developers in any way, the CMF does not install any predefined or final customer data class, but allows the developer to define the data model as needed. The only requirement is that the customer class needs to implement a certain interface in order to be used in the CMF context. There are a couple of ways of doing so. The recommended way is to create a data object class named customer and define the abstract customer that is shipped by the customer framework as a parent class. In addition to that, it's necessary to add the following attributes directly to the customer class. In order to speed things up, we also provide a class definition, which can be used, extended, and modified as needed for the certain use case. Of course, if you don't want to have these attributes at the top level of your class definition, you also can create certain getters that are named the same as the attributes and then retrieve the data from wherever it is located in your data model. If you want to use the Pimcore data objects as users for the Symfony security, there is another parent class that needs to be extended, which is the default abstract userware customer, which provides the necessary functionality to enable the customer data objects to be used in the Symfony security, and also there is then an additional attribute needed, which is the password field. If you want to use the single sign-on functionality provided by the framework, you additionally need to implement the single sign-on aware customer interface, which provides some additional methods and also the single sign-on identities attribute. If you don't want to extend the abstract classes, you also, of course, can just implement the customer interface that is shipped by the framework, and also all the functionality that is provided by these abstract classes is available as traits. So you also can just configure the traits in your class definition and so retrieve all the additional functionality. And that's pretty much all that it's needed. And let's quickly have a look at the demo application and how it's done there. So we have some class definition, which is called customer. There we have the parent PHP class, which is called the default abstract user aware class. and we have added all the necessary attributes there and also some additional attributes that are needed for our demo use case. In addition to that, we use the class override functionality to add a custom subclass where we implement an additional method here, which is needed for our implementation, for our demo application, but this is only an optional thing there. And that's about it, how to configure and set up the customer class to be used for the customer management framework.
Now that you have a good overview of the customer management framework, its architecture and its functionality, it's time to get started. First of all, it's important to know that the customer management framework does not ship with the default distribution of Pimcore. It's located at a separate GitHub repository and needs to be installed from there. Let's have a look at this GitHub repository.
The repository of the customer management framework also contains all the documentation in the README and subsequent pages, and this documentation contains the architecture overview we saw in the previous courses and also all the installation instructions you need to follow to get the system up and running. Since the customer data management is not a part of the core distribution of Pimcore, you need to install it via Composer by just requiring the Pimcore Customer Management Framework Bundle repository, and let Composer do the rest. And after Composer has installed all the sources, you need to install the Customer Management Framework Bundle within Pimcore. Either do it via the extension manager in the Pimcore backend interface, or use the console commands provided by the Pimcore console for installing Pimcore bundles. The installer installs several data object classes, like for example the segments and the segment groups. It creates additional tables for activities, for deletions, for segment building, for actions, for triggers, rules, duplicates, and the newsletter system export. And it also adds additional user permissions to specify permissions for the Pimcore backend users. So now for getting started with the customer management framework, there is one important step left, and this is setting up the necessary cron jobs that are needed by the customer management framework. And these are linked here in the installation documentation, and these cron jobs are needed for certain background tasks that certain functionalities of the customer management framework. We'll have a look at these functionalities in detail in later courses, but during the install you should also directly set up the necessary cron jobs, which are listed here. There is a segment building queue, there is an action trigger queue, there's a cron trigger, there is this calculate potential duplicates cron job, and then we have the CMF maintenance cron job. These cron jobs are mandatory, except you don't want to use the duplicate service, then you can spare this one. If you want to integrate the newsletter synchronization with MailChimp or something like that, then you also need to set up the newsletter queue here and the MailChimp status sync in order to make sure that the synchronization between Pimcore and MailChimp takes place.
For the iframe reports, let's have a look at how this can be done. The first step, of course, would be to create a default controller and some action where we visualize the things that we want to visualize, so the reports or the dashboard or whatsoever. In our case, we just create a very simple controller action, which is just a simple text response right now. And of course, we define a route for this controller action. Then the next thing is that we want to add an additional button in the menu somewhere, in the main menu, to open up this report. And this can be done within a bundle, for example, within a Pimcore bundle, where we create an event listener for the Pimcore Ready event. And this lines of code here show how we can add an additional button. Actually, we first get the current user and check for some user permissions, whether we really want to add this menu or not. Then we want to get the toolbar, and since we want to add a menu item to the settings menu, we get here the settings menu. And then actually we just add an additional item to the settings menu here, which has a certain text, can have some things like icons and these kind of things, and most importantly has a handler. And the handler is the function that is called when we click this menu item, and there we try to open up a certain panel, and if this panel is not available, we create this panel. And since we want to have an iframe window, we use this Pimcore tool generic iframe window here, and here add the panel ID, add the route to the information we want to display here, and then we also can specify an icon class and some title text. And once this is all defined, we can go back to our Pimcore backend and here open up the settings menu. We have here our additional menu entry, which is added, and then it opens up an additional window and visualizes the data that is provided by the specified route.
And then, once the mapping is set up, we can continue with the last step, which is executing the import. As soon as the configuration is saved, we can execute it manually right away by just clicking this button, and then the import is prepared and executed in the background. There we also see the progress information and see also if some import is running in the background. In addition to the manual execution, we also can configure a cron definition to execute the import on a regular basis, for example once an hour, once a day, or whatever interval you need. Important for this cron definition is that the definition is also activated here in this general tab, otherwise it won't be executed. And once the execution is finished, we also should see the data imports in our data objects here, where we see all the data objects with the nice key, where we have this manufacturer, the name, and the article number here. And when we open up the data object, we see the name assigned, and we also see the manufacturer relation assigned. Every execution of the import also produces some log information to trace what happened during the import, and these logs are added as application logger entries and also can be accessed directly here in the configuration in this import logs tab. There we see exactly what happened during the import, which data elements were imported, what problems occurred. We even can directly open up the imported data objects, and we also see the raw data that was processed from the data source for the corresponding record. And then finally we come to the third and probably the most important section, the mappings section. Here you configure to what data attributes of the data object the data of the data source should be imported to. And for that we need to configure a mapping for each field that we want to import. And this can be done by just adding here a mapping entry, and there we need to configure a couple of things like enable, that we know what data we want to import here. Then we define one or multiple source attributes. Let's maybe start with the model attribute. And then we have already a preview of the data that we are going to import. And then we need to assign this data to a data target, so to the data object somewhere. In this case, we want to assign it directly to a data attribute, which is in our case called the name attribute. And since the name attribute is a localized field, we also need to specify the language we want to assign it to. Optionally, we also can define a so-called transformation pipeline that allows us to do some simple data transformations. Like, for example, we can trim the data so that we don't import any white spaces that we don't want to import. This transformation pipeline thing is actually quite a powerful tool. For example, we can import data and create as a unique key for our data object. So let's just call this key. And for the key, we now want to choose manufacturer, model, and article number. Now we see that this data is now imported as an array, and we need to transform it to a key string. And for that, we just choose a operator which is called combine, and we glue it together with a special sign here. And there we see already the updated preview. What we also see here is that we have there a white space in there. So what we need to do there is that we also add a trim operator, do it before we combine the data. And now our preview is already updated, and we see that the white space is gone here. And now we can again assign this to the data target, which in this case is now the key of the data object. And so we can configure all the mappings. Another example would be, for example, to import the manufacturer. Here we see that the manufacturer is a string, but in our data model, the manufacturer is actually a relation to another data object. So we now need to load the data object and assign the data object to our newly imported object here. And again, for that, we can use the transformation pipeline with a special operator which is called load data object. And this one loads us existing data objects. In this case, we want to load it based on an attribute. We want to load the manufacturer, and we want to load it by the manufacturer name. And there we see already in our preview that now the import can load existing manufacturer data objects, in this case the Ford object, and now we can assign this data object to our manufacturer relation from our data object. The nice thing here is that we always get the updated preview of our transformation pipeline, and that we also can navigate through all the different records of our preview file, and the preview in our mapping is also updated right away. What we also see here now is that it also marks us all the data fields that are already mapped of our data source with the screen, so that we have a nice overview of all the mapped data attributes. And so we can continue and map all the data and set up our import. In our demo application, we have also configured an import with some additional examples for the data mappings. And I just want to have a look at a couple of them. For example, let's have a look at the horsepower here, which is provided as a string with a white space in between the value and the unit. And we want to assign this to a quantity value attribute. And to do so, we define the mapping and again use the transformation pipeline. In this case, we first explode the data with the white space and then use the asQuantityValue operator, which takes this array that is the result of this explode operator and creates a quantity value, and then we can assign it to quantity value data attributes. At this point, we also see that we not only are able to choose direct class attributes of the data object class, but we also can assign to data object brick attributes. In this case, we have this engine data object brick, and there we assign this to the power attribute. Another example is the main image, which in the import is provided as a URL to an image file. And we want to, of course, import this image and assign it to our gallery attribute. Again, we use the transformation pipeline here. There we have an import asset operator, which downloads the asset from the remote location and saves it as an asset in the specified path. And then we use also this asGallery operator to get a gallery data value, and then we can assign it to the gallery field of our data object. And last but not least, I also want to have a look at this categories here, which is provided as a comma separated string. And we want to use this and assign it to our categories many-to-many relation. Again, we're going to use the transformation pipeline, explode the string with the comma here, and then use the load data object operator, this time load by ID. There we see we get then a data object array with all the category objects, and this we can then assign to our many-to-many categories relation. And there are many more options you have, and of course it is also possible to extend the transformation pipeline with custom operators if needed. Next step is to configure all the import settings, and there an optional but quite useful thing is to start with the import preview. A preview of the import data will help you to set up all the other settings, and so yeah, it's really recommended to set up a preview. To get a preview, we have two possibilities. Either we can upload a file from the file system that has the same format and the same structure as the configured data source, or as an alternative, we already can read the data from the configured data source and use this data as a preview. Let's maybe just do this, and there we see already the preview now. Important to know at this point is that the import preview file should of course contain all the possible fields the import can have, but it should not contain too much data rows, as this will have performance implications when loading the preview data. So choose your preview source wisely. Most likely it will be a specially prepared file that just has a couple of records, but of course all the possible data fields of your data source. Once the preview is loaded, you can reload it here and also navigate through all the data records using these buttons. The second section of the import settings contains a couple of processing settings that allow you to further adjust the import process. For standard imports, you most likely can skip this section and just use the default values, but for completeness, we also need to discuss these options right now. The first one is the execution type, where we can specify if the import should be executed in a sequential or in a parallel way. In terms of import performance, importing in a parallel way has advantages, but sometimes the import cannot be executed in a parallel way. For example, when imported data rows depend on each other, they maybe build up a tree hierarchy or make relations with each other, and in this case we can choose the sequential, and if we choose this, then the data will be imported one by one in exact the order of the import source. The second one is the archive import file option. If activated, the imported data will be archived for later traceability, so you can find them then in the import logs. But be careful, depending on the frequency and the data amount per import, this can easily fill up your data storage. The next two features then require a unique identifier in your data source. So we need to define this unique identifier first. And this is this setting here where we can choose the column of our import file, which is the unique identifier of our data records. So for example, the article number here. And as soon as we have defined this one, we can use the delta check feature and the cleanup feature. The delta check feature is a feature that checks for each data import row if the import data has changed since the last import, and only imports the data if it has actually changed. Important to know at this point is that it only checks the import data stream. It does not consider if the data object itself has changed in the meantime. So it's really just for the import data stream. And the second feature there is the cleanup feature, which allows you to clean up elements that are not part of the import file, and then they are either unpublished or deleted. So this means that it looks for other data objects of the configured data object class and then cleans them up if they are not part of the import source. Important here is that for make that work, you always have to provide a full import. You cannot do delta imports with these options activated here, because if you would do, then after each import, each delta import, the not contained elements would be cleaned up, and this is not what you want at this place. For all data objects, so for the newly created ones and also for the existing ones, the element location update strategy is applied. And this gives us the possibility to move the data objects to different folders. There is the no change strategy, which doesn't do any changes at all. But there are also two alternatives that we already know from the element creation, where we can specify either a static path, so all the updated data objects will go into a different folder that can be specified here. Or as an alternative, we also have again this find parent strategy, where we again can define the find strategy with ID, path, or attribute, define the data source index of the import file, and also define a fallback path if the parent is not found. For now, let's keep it for no change, because we don't want to update the location of the data objects. And then, last but not least, we have this element publishing here, which defines if the data objects should be published or not. Again, we have a couple of strategies. We can always publish the data objects. We can do no changes, but publish the new ones, so the new created data objects. We can do no changes to existing ones and unpublish new data objects. And we also can specify the published state of data objects based on a data attribute of the data import. So there we again could choose a column of our data import and specify the published state based on this data attribute. For now, let's do no change and unpublish the new ones, and let's save the configuration. If we set here the no loading strategy, or also if the other strategies for the element loading don't find any elements, then the element creation comes into play, which defines at which location the new data objects should be created. There we have two strategies available. The first strategy is the static path strategy, which allows us to define a static path, and then all the new data objects are created at this specified path here. The alternative is to use the find parent strategy, which looks for existing data objects or folders based on a finding strategy. And again, there we have these three strategies that we already know from the loading strategies here. So we can look for parents by ID. Again, we need to specify the column of our import where we have this parent ID stored. We can look for parent elements by path. Again, we need to specify the column of the import where the path is stored at. And we also can load the parent element by a data attribute. In this case, it needs to be a data object, so we cannot search for folders by attribute. And there we can then choose the data object class. So for example, let's just choose the category. Then we need to specify the attribute name of our data objects. So let's, for example, choose the key. And then we again need to specify the column of our import where this data attribute is stored that should be looked for. If the find strategy doesn't find any parent, then we still can define a fallback path where all the data objects will go into when the parent is not found. For now, let's just choose a static path here and call it, for example, demo import. So now that we have a nice preview available, we can start with the actual import settings. And there the first section is called resolver and defines where the data should be imported to. So it resolves the import target. As the data will always imported as data objects, the first setting defines the data object class of these data objects. So let's choose a data object class here, and then we can start with all the other settings that define which data objects should be created and where these data objects should be created. The element loading section defines the loading strategy for existing data objects. So there you can specify how to look for existing data objects when importing the data. There we have different strategies available. First of all, you can, for example, look for data objects by their ID. For that, you also need to configure, of course, a data source column where the ID is stored in the import so that the import can look then for existing data objects. Similar thing is available for the path. So you also can look for the data object paths. Again, you need to define a column of your import where the path of the data object is stored. And it is also possible to load data attributes by any other attribute, for example, any article numbers or these kind of things. There again, we need to first define the data source index, so the column of your data import where this additional attribute is stored, for example, article number here. And then you also need to choose the data attribute of your data object class where this, in this case, article number would be stored in. And then last but not least, you also can specify no loading here. That means that no elements are loaded, so always new data objects are created.
An example for the inline reports you can find in our demo advanced. Here in the product class, we use the calculated values for calculating the data quality for certain attribute groups. And then we also use the dynamic text labels for creating a summary of the data quality. The calculated value is a normal data type for Pimcore data objects, where you can specify a so-called calculator class, which contains the calculation that you want to do. And there, of course, you can either do some calculations like summing things up or these kind of things, or you also can use them to calculate, for example, the data quality. Similar to the calculated value, there is this dynamic text label also within the data object, which is a layout component. And there you can specify a so-called custom renderer class. And this custom renderer then can render a certain summary, for example, of data quality or whatever other information you want to visualize directly inline in the data objects. In addition to this dynamic text labels, there is also a pretty new component which is called the preview iframe, which is mainly specified for previewing certain information like a teaser or something like that of the data object data. But it also can, of course, be used to visualize inline reporting based on the data that is stored within the data object or is available in general. The basic idea is that the Statistics Explorer needs a host application where it's running in. It does not run out of the box and stand alone. The host application needs to provide user management and the whole context of the application. And this basic concept also explains all the necessary steps for installation and integration of the Statistics Explorer.
All the necessary steps are listed and explained in the documentation, so let's have a look there. First of all, we need to install the bundle. That follows the standard Pimcore ways. That means download it via Composer and using the commands of Pimcore for enabling and installing the bundle. And then it's ready for configuration, and for the configuration it's important to know that the architecture of the Statistics Explorer requires that it is embedded into a host application that provides the whole context, the whole environment for the Statistics Explorer, most important, the user management and the currently logged in user. It is also possible to execute this Statistics Explorer in multiple contexts within one Pimcore instance. That means you can integrate it into the Pimcore admin interface, you can integrate it into a customer portal, and into any other app you have created with your Pimcore instance. Each of these contexts needs to have a name, like for example Pimcore admin, portal, frontend, whatever name you choose. And then these contexts also can have different data sources, and different users. Speaking of users, this is the next thing we need to set up. And there we need to set up a so-called user provider, which is responsible for providing the currently logged in user and also all the other users and roles to the statistics provider. This is especially necessary for saving the configurations and sharing them with other users. User providers are Symfony services that implement the user provider interface and that are tagged with the user provider context. And the tag configuration also has this context parameter that defines for which context this user provider should be used. Next, we need to set up the routes. These are the routes from which the Statistics Explorer loads the data from. And since we want to give the host application maximal flexibility in terms of the routes, the Symfony firewalls, and all these environment things, the bundle itself does not define any routes. They have to define within the host application, for example, by adding an entry similar to that one to the routing YML. And there we can load all the final endpoint URLs from this controller here, which are defined as annotation there. And then we need to define a prefix, which of course is defined by the host application. And this results then in actual endpoint URLs that look as follows. First we have the prefix that is defined, then we have the context name, and then we have the actual endpoint URL. And this is important to know for the integration. More on that later. Next thing is that we need to set up the data sources for the contexts. Again, data sources are Symfony services that implement a certain interface. It's the statistics storage adapter interface, and they are also again tagged with a special tag here. The bundle already ships with two default implementations for these data sources. We have an Elasticsearch adapter and a MySQL adapter that loads the data from either an Elasticsearch index or from a MySQL table. And here the configuration then looks similar to these ones. So we have some additional arguments that we can provide for specifying the index name, the table name. We also can specify the label that is shown then in the Statistics Explorer user interface. And then it's important to provide the tag here with the data source. And there we have also the possibility or the need for providing an internal data source name, and also, of course, the context for which this data source should be available. It is also possible to define multiple tags here and so make this data source available to multiple contexts. And that's about it. Now the Statistics Explorer is ready to be integrated into your application. When integrating the Statistics Explorer to your application, you have two possibilities. Either you can integrate the whole Explorer app, as we see it here in this screen and we saw it at the beginning of the course, or you can integrate the so-called statistics loader. This allows you to load just one or multiple reports of saved configurations and create pages like this one here, where you just have a couple of reports in one page in your application. Let's start with the integration of the whole Explorer. This is of course again documented in the documentation, and there are a couple of steps necessary to do so. The first one is that the Statistics Explorer uses Bootstrap markup. And for that, of course, it makes sense to include the Bootstrap style sheets unless you have it already integrated in your application anyway. The second step is to include the Statistics Explorer style sheets. We can do this via Symfony Webpack and Core. Then we need to define a markup node where we want to place the Statistics Explorer into. Then we need to provide a JavaScript configuration object, which contains all the URLs that are used by the Statistics Explorer. And these always follow the scheme prefix that you have defined in your routing, then the context you want to use for this integration, and then all the endpoint names of the corresponding URLs. And then last but not least, we of course also need to include the JavaScripts of the Statistics Explorer. Again, we do this via Symfony Webpack and Core. And the sample integration could look like as follows. First, we have the Bootstrap markup. Then we have the Statistics Explorer markup. Then we have this node where we want to inject the Statistics Explorer to. Then we have this JavaScript object for all the configuration URLs. And last but not least, we integrate the JavaScript sources for the Statistics Explorer. The integration of the statistics loader follows the same principle. So again, we need to include the Bootstrap styles. We need to include the statistics loader styles in this case. Then we have some markup we need to define. In this case, it's not just a node, but also a data config ID where we define the name of the configuration that we want to load. Then we have again this JavaScript object with the URLs. In this case, we only have 3 of them. And last but not least, we need to provide the loader scripts for the statistics loader. Again, this can look like as follows. Here we have the Bootstrap styles. We have the statistics loader styles. We have the configurations, the markup nodes, where we have 2 of them in this case. First with some configuration ID and the second one with some configuration ID. Then we have the JavaScript object with the URLs, and last but not least we have again all the scripts for the loader.
Besides an overview of the Pimcore admin interface, you also should get an overview of the installation package itself.
To do so, let's go back to the Pimcore application and open up the Server File Explorer, which shows us all the files and directories on the file system of the server. Pimcore X is a Symfony 5 application, and also the folder structure is pretty much standard of Symfony and of the Flex structure. So if you know already the Symfony folder structure, you should also be quite familiar with the Pimcore folder structure. Let's discuss a few aspects in detail, as for example the Composer JSON, which is the central point for all the management of third-party libraries. And also actually Pimcore is nothing more than such a requirement and dependency, as you can see here in this line. You can modify this Composer JSON to your needs, adapt it, extend it with all the dependencies that you need for your application. In addition to the Composer JSON, let's have a look at the directories we have here. First of all, the bin directory, which is Symfony standard and contains all the executables like the Pimcore console, which we will meet in further courses of this training. The next folder, the config folder, is also Symfony standard and contains all the configuration files for your application. There you also can utilize the Symfony environment system, which allows you to define different settings for dev, test, and production environment. In addition to the standard folders of Symfony, there is one additional folder, which is the Pimcore folder, and this Pimcore folder also contains some additional Pimcore-specific configuration files. Next folder is the public folder, which is also a standard and is the document root for your web server and contains all the files that should be public available, like for example any static files and any JavaScript files, CSS files, these kind of things of your application itself, and also of course of all the bundles that are installed in your application. And in addition to these static files, there is one special additional var folder, which is Pimcore specific, and this contains all the files that are managed within Pimcore in the Pimcore assets and should be public available. We will discuss this public var folder in a later course when we discuss about assets and how Pimcore manages the assets. Then there is the source folder, which is again Symfony standard and contains all the project's PHP code. Then we have the templates folder, which is again Symfony standard and contains all the templates of your application. Same goes for the translations folder, which is also Symfony standard and you can use if you want to ship additional translations to the shared translations of Pimcore. Then we have the var folder, which is again a Symfony standard folder, which contains all the private generated files of Symfony and also of Pimcore. So there are a few folders which are standard to Symfony, like the cache folder, like the log folder, for example. And there are a couple of folders specific to Pimcore, like the classes folder here, like the versions folder, for example, also the temp folder. So we will discuss these folders in later courses of this training a bit more in detail. And then last but not least, we have the vendor folder, which contains all the third-party libraries, which is standard for Composer applications. When you install the demo package, so not the skeleton as we have here, but the demo package, there are some additional folders like a dump folder or something like that, which for example contains all the sample data of the Pimcore demo installation, and this folder, for example, can be deleted after the installation. Bottom line is, Pimcore tries to follow Symfony standards, and so the folder structure of a Pimcore application should be pretty much standard and pretty much familiar to you. Once all system requirements are met, you can start with the installation of Pimcore. The installation follows industry standards and is based on Composer, and we provide two different installation packages. There is one skeleton package which installs an empty Pimcore instance, and there is this demo package which installs some demo data models and some demo data. You can use this demo package for testing Pimcore, for demoing Pimcore, and it also can be seen as some kind of a blueprint application of Pimcore. Actually, this demo package we also use for our public demo instances you find on our website. To start, you need to use this create project command of Composer and then define the desired installation package, and then Composer installs all the needed requirements and dependencies of Pimcore. This process actually needs some memory. It's a bit better with Composer too, but still you need to make sure that Composer has enough memory for all the dependency calculation. Once Composer is finished, you need to make sure that your web server has its document root to the newly created public folder. And as soon as this is done, you can follow the next steps, which are creating a database and then launching the actual Pimcore installer, which can be found under vendor bin Pimcore install. This Pimcore install command has some additional parameters you can define. Just use the help of this Pimcore install command to see all the possible parameters you can set here. The Pimcore installer then creates all the necessary database tables, creates some configuration files like the database YAML and also the system YAML, and finishes the installation of Pimcore. And once the installation is finished, you are ready to open up the admin interface of Pimcore and start working with Pimcore. If you face any problems, then also have a look at the var directory for any log files. Most probably there are some hints for the reasons for the problems you have. And last but not least, after installation is done, it's important to set up the maintenance job of Pimcore. This is a script that should be executed on a regular basis, for example, every 5 minutes. And this is important for certain cleanup jobs, for different things that Pimcore needs to do on a regular basis. And if you don't set this up, Pimcore will fill up your database quite fast, and also some features won't work as expected. But then you're ready to go and work with Pimcore.
As already mentioned, we highly recommend a Linux-based environment for installation. But in times of Docker, the host system shouldn't really matter anymore, at least in theory. Our experience shows that Docker in combination with Windows as a host system has its problems, especially performance-wise when mounting volumes to the local file system, which is quite mandatory when you develop for Pimcore. But in combination with the WSL, there is a solution which I'm going to show you now.
What I want to do now is to install the skeleton package of Pimcore from scratch. The time it takes, of course, depends on the performance of your PC and the speed of your internet connection, but it should not take ages. I added the clock here on the side that you get a feeling of the time that is needed on my instance here, which is by far not the most powerful. Requirement for this is to have WSL and Docker installed on your Windows system, because then you can run Docker completely inside your WSL environment and also do the mounts directly within the Linux file system. So important is not to use this default mounts to the Windows file system, but really switch to the Linux file system, for example to the home directory, and then there you can start with the composer create project command. You can run this again also inside a Docker container, or if you have installed PHP and Composer directly in your Linux environment, you also can execute this directly. Once Composer is finished, we have our project directory with all our dependencies in the vendor folder and also the skeleton data here. And we also have a Docker Compose file, which already defines us a few Docker containers that we need for the Pimcore instance, as the database, as a Redis, and also as an application server. And this Docker Compose file we just use now to start up our Docker environment with Docker Compose up. And as soon as our containers are up and running, we can start with the Pimcore installation. For that, we again just use the install command of Pimcore, define the database and database credentials, and then it's just asking us the admin username and the admin password, and then the installation starts. And then installation is done. In some Composer environments, it's necessary to define the ownership of the files in the Docker container to the user that is running the web server. Otherwise, you have some file access problems. We have already tried to fix this and are working on a fix on this. But let's just do this. And as soon as this is done, we can switch to our browser and start the admin interface with localhost admin in this case, and then we should be able to start Pimcore admin interface. Just log in, and there we go. We now have a finished installed instance of Pimcore that we can use here. If you now like to access the mounted resources within your IDE, you can access this via the virtual network that is created by the WSL. Just move this here that you see this. So there is this WSL, then your instance name, and then the path in the Linux file system where you can access the files directly in your Linux VSL environment.
Since there is a lot of development going on in this topic, please also check out the latest developments and documentations. Maybe there is already a better solution for developing with Windows. For Linux-based environments, this should be much easier, as we don't have the performance bottleneck when mounting the volumes. Hello and welcome to another session of Pimcore Insights. This time it's once again about personalization and behavioral targeting. In the last session I showed you the 4 necessary steps to create personalized experiences with Pimcore Experience Manager. This time I want to go one step further and show you how to integrate this functionality with the e-commerce functionality of Pimcore. Let's say we want to create a landing page and list a bunch of products, and we want to personalize this list of products to the visitor's behavior. To do so, let's just jump once more back into the Pimcore backend and see how this is done with our e-commerce demo application. First of all, we need to create a landing page. So let's just do here, create a landing page, call it special offers, for example, and then we add some headline,
For example, these are our special offers, and we create a product grid, and this product grid always needs a so-called filter definition that defines which filters are there and which products should be shown. So this actually defines the list of the products. Let's just use an existing filter definition for the global generic version of our landing page. And yeah, let's just save it and have a look at our preview. And there we see, okay, we have our special offers, we have some filters here, and we have our product list. Next step would be to create the personalized variant of this landing page here. To do so, we use our menu here in the left bottom corner and choose our target group. In this case, we maybe just choose once again our outdoor lover target group, which we created during our last session. And now we can personalize our landing page. For example, we just change the title and say these are our special offers for outdoor lovers. And of course, we want to personalize the product listing. And for that, we need to create a new filter definition. Let's just create here outdoor lovers once more. Let's put in some settings that are necessary. We want to filter for a certain product category. In this case, we want to filter for the outdoor products. So let's just go for our category tree here and say this should be pre-selected for the category outdoor, include the subcategories, and then we maybe add some filters that should be shown. Let's say, for example, we want to enable to filter for the gender here and select the gender field, and we maybe want to add another filter here and filter for the color attribute of our products. That's so much for the configuration of our product listing, and we need to assign this filter definition to our document, and this is again just done via drag and drop, and save the document, and this should be pretty much it. Let's again just test this if this is working all correctly. For that, I activate once more the targeting toolbar, go back to the front end, open up our special offers landing page, and when I open it up without any special settings, we see the generic version of our landing page, and then we switch again our target group in the targeting toolbar, apply this one, and tada, there we see our different title here and our special outdoor products that are personalized now for our outdoor lovers. This is now quite an easy example of how to integrate e-commerce with the Pimcore Experience Manager. Let's just go one step further and not just personalize the presentation of products, but also even the behavior. Let's say we want to create an additional gift product that we put into the cart when a certain target group, for example our outdoor lovers, do some purchasing on our e-commerce shop. For that, let's go back into the Pimcore backend, and of course let's first of all create this gift product we want to give away for our outdoor lovers. So let's say this is our outdoor lover gift product. We give this product some name, outdoor lover gift product. Let's put some article number here, and maybe we add an additional image. As it happens, I have prepared already one gift image, which we just added here now. Let's save this product. This should be pretty much about it, what we need here. Of course, we don't need all the detailed information that we would need for a normal product.
Now that we have our gift product, we need to configure a special pricing rule that adds this gift product to the cart when certain criteria are met. And for that, we create pricing rules here. Say we have our outdoor lover gift pricing rule here. Outdoor lover gift. We say this should be not the last rule. Of course, we need to activate this rule, and let's define a few conditions. For example, we say this is only valid in a certain date range, and we of course filter for a special target group. Let's say we filter for our outdoor lover target group, and that's our condition for our pricing rule. And let's define additional action, which is actually the gift. And there we configure our gift product that we previously created. Save this pricing rule and let's go back to our front end and see if this works as expected. Let's first of all make sure that we are again an outdoor lover as target group, so this should do the trick here. And let's maybe go back to our portal page. There we see we have outdoor lover, and let's just put one random product into the cart, and as what we see here is that automatically this additional outdoor lover gift is added to our cart. Let's maybe just double check, create an incognito window of our shop and just add a product as a non-outdoor lover into the cart, and there we see no gift item is added to the cart. And this is another easy example how you can integrate Pimcore standard functionality with the Pimcore personalization functionality. And that's about it for this session. In the next sessions we dig a bit deeper into the technical details and how you can customize this functionality even more. And for that, stay tuned and see you there. Bye bye. Last but not least, let's have a look at the database structure that is generated when you using localized fields. Again, Pimcore is storing the localized fields data in a nice way, meaning that for each attribute we have an additional database column. Again, like with the normal data objects, we have two tables. We have a data table, which is the actual data store, and we have a query table. Actually, we have multiple query tables for each language one, which is the query table with the query index that contains all the relational data too, and also the inherited data. When we have a look at the data table itself, we see nice table structure with title and short description as separate columns. And we also see the language here as an entry. That means all the data or all the languages are stored in separate rows here in the data table. The query table looks pretty much the same, just with again also the inherited data. And now when you're using object listings and applying conditions to them for object classes that have localized fields within them, the query is not executed on the object underline class ID view, but it's executed on a localized view for the current active locale, again with the same mechanism I explained before. And the localized view is actually just a join of the objects table, of the normal query table, and of the query table for the localized fields of the current locale. Let's have a look in Pimcore backend how this actually works. For that, let's open up our class definition. I prepared here a test class, which is right now empty, and there we are going to add localized fields, which is a structured data type, here localized fields, and the localized fields allow you to add sub-attributes, again, of most of the data types that Pimcore allows you to add, and all the attributes that you add below the localized fields will get localized. So for example, let's just add a title field here and maybe a short description field. Short description. And let's just save the class here and create a data object of our class. And there we see we have our two attributes, the title and the short description, and we have it not only in one language, but we have it in this case in two languages. So we can specify an English title, for example, and an German title, or Deutscher Titel in this case. Which languages are available is defined in the system settings. So we have here the system settings, and there is localization and internationalization part, and there we define which languages should be available in the system. The languages you can choose from are basically the ISO standard, and there it's not only the locale itself, but also the locale with the region. So for example, you can of course add French as a language, but you also can, for example, add the Canadian French or the French French or the Belgian French if you need to manage different content for these different languages or dialects or regions of a certain language. And yeah, if you just add a language, save the system settings again, and then you need to reload Pimcore, but this is actually everything you need to do, and then you have an additional language available in, for example, your data objects. In terms of the generated API, Pimcore of course also supports for localized fields, getters and setters. Actually, this works completely the same as for the other class attributes. So you have just a getter, which is in this case, for example, get title or get short description. But the difference in this case is that you can provide a language parameter, which then specifies the language that should be getted, or of course the same also applies for setting the data. Let's just switch back to the IDE and create a sample for that. Let's just get our test class get by ID 53 it was, I guess, and then let's just, for example, echo sample get title, and let's say we want to print out, for example, the English title, and then we have a look if it's working. Let's hope that no error message occurs, and there we see our English title, and we change our parameter here for DE, for example, then we get of course the German title back. As you maybe already noticed, the language parameter here is an optional parameter, and you can also skip it. If you skip the parameter, then Pimcore tries to find the current active system language. And yeah, we need to discuss this a bit, how this is taking place. The absolute fallback, if Pimcore cannot find any language, is the English language. But if you are, for example, in a controller context, then Pimcore tries to get the language out of the corresponding document. That means Pimcore checks the current URL and sees if there is a document for it, and if it finds a document, then it takes the language that is defined in the document. So we have this here in the system properties, where is the language defined. If you are in the context of a static route or a Symfony route, then Pimcore still tries to find a fitting document. And as in our example here, where we have the URL en and academy, Pimcore tries to find the most fitting document. That means Pimcore tries to skip URL parts. For example, in this case, it would skip the academy and sees if there is a document en, and if there is no document en, then it would also skip the en, and at least you will always have the root document available in a controller context, and Pimcore will always take the language of the root document if it doesn't find a better fitting document. In our case here, Pimcore will find the en document, and in the en document we have set up, of course, the English language. That means when we call our getter without any title, as we did it here, then I suspect or expect that we get the English title back as a result. The same, of course, also applies to the setters. So, for example, now I can, of course, modify my localized data here, for example, by setting set title and say, some other English title, for example. Again, optionally providing the language locale or not. And of course, I also can set different locale data in one request. For example, let's just also set the French title and save the object here. Let's again execute our controller action here and reload our document and our data object, and then we see already we have the French title set and also the other English title. Hello and welcome to another session of Pimcore Insights. This time it's again all about data objects, and there especially about advanced data types and advanced configuration options that Pimcore provide. The first data type we discuss is the so-called localized fields data type, which allow you to manage localized data within data objects. In documents, we said each document only has one language, and if you want to manage or create multiple language websites, you have to create multiple document trees. In data objects, this is a bit different. In data objects, we only have one object for all the languages, for example, one news object for all different news languages, or one product object for all different languages. And we use this so-called localized fields for managing the multi-language attributes of this object. So, as you can see, with custom automation rules, a couple of things can be achieved directly out of the box. To implement additional use cases, it is also possible to implement custom elements for these custom automation rules, meaning create custom triggers, create custom filters, and of course also create custom actions. And generally you have to decide when it makes sense to use the custom automation rules and when it's better to implement the automation directly with PHP code, like with PHP commands or something like that. I would say custom automation rules are an awares and pitch feature. They are great for simple use cases when the editors want to fiddle around with the parameters, but for more complex use cases, I would go for implementing them directly in PHP code. But I'm also more a developer than I'm an editor. The CMF also ships with a simple marketing automation engine called Custom Automation Rules. With this engine, it is possible to create simple rules and automate certain workflows and use cases. The easiest way to explain it is to show it in action. So let's once more have a look at our demo application.
The custom automation rules are defined here in this custom automation rules editor, which allows you to define multiple rules. And let's just add another rule and discuss all the options we have here. First of all, we need to define a name, then we can define a description, and we need to define whether this rule should be active or not. Each rule then consists of 3 major parts that define the actual behavior, and these parts are the triggers, the conditions, and the actions. The triggers define when the rule should be executed. So all the rules listen for certain triggers. There we can choose from certain things like if a new custom activity is tracked, if we want to execute it on a regular base based on a cron definition, whether it should be executed once the segment building process is running, or also events that come from the Pimcore targeting engine, like whether a segment is tracked or a user is assigned to a certain target group. Let's maybe start with a custom activity tracking event and choose from certain types here. We now choose the customer login type. The second part are the conditions, which are optional because you also can choose not to define any conditions and then the actions are executed all the time. But with the conditions you can restrict when the actions should be executed, for example by counting activities of a certain type, by filtering customers for certain segments, by filtering customers at all, or also for example filtering for certain customer fields. For example, we can now filter for login activities that should be bigger than, for example, 10. And we also can add an additional condition here, specify whether it should be an AND condition or condition, and specify here quite complex conditions actually. And the third part then are the actions that should take place once the conditions apply and the trigger is triggered. And there again, we can choose from different actions here. We can change certain customer field values. We can add segments based on different aspects to the customer object, or we can send emails to the customer. Let's maybe just add a segment and say we want to add the VIP customer segment here to the customer once he logged in multiple times. The add segment action is actually quite a good example to discuss 2 more aspects concerning the actions. First aspect is this action delay here, which we can specify, and with that we can decide whether the action should be executed right away when the trigger is fired, or we can delay the action by certain minutes, hours, days, whatsoever. This has of course 2 aspects. First of all, there is a semantic aspect when we want to decide, okay, we want to send an email 1 day after the order took place, or whatever other semantics we might have. And the other aspect is a performance aspect, because when we don't define any delay, then the actions are executed right away. For example, every time the activity is tracked, which could cause certain longer runtimes. And once we define also just a small delay, then the actions are executed asynchronously by cron jobs. And the other aspect we can discuss here with this add segment action is this consider profiling consent, which is ticked by default and also available for other actions, like for example for the send mail action here. And this checks whether the current customer has consent to profiling actions and therefore makes this whole customer automation rule GDPR compatible. And that's about it already with the possibilities we have here. And with these options we have here, we can now configure certain use cases and custom automation rules. Like for example, we can specify that an email should be sent after every time an order is taking place, or that customers should be classified for certain customer types, like for example for VIP customers, when customer orders are, for example, more than 5 times at your shop or whatsoever. So with these options here, you can configure already quite a lot of use cases.
Let's have a look at all the modules that ship with the e-commerce framework. And by doing so, it's often quite useful to have a typical e-commerce application in your mind. Typical e-commerce shop where you have product listings with filterings, with search, at some point then product detail page with all the product information, with all the price information, with ability information, these kind of things, and then at some point possibility to add products to a cart, and from the cart you have then the possibility to check out and make some payment and then finalize your order. Because having these typical workflows in mind makes easier to explain and also understand the modules and put the modules in the correct place. Let's start with the first module, which is the index service. And before we can explain the index service, we need to repeat a basic principle of the e-commerce framework when it comes for data modeling. Because the e-commerce framework itself does not force you in a certain data model for products or for categories. It tries to allow you to use the whole power of the Pimcore data objects and really model all the product information that you need, all the structure, all the possibilities that Pimcore itself provides you when it comes for data modeling. And most of the time you don't want to consider query performance, filter performance when you model the data, because the primary goal when modeling the data is to really model all the available and necessary product information into your data object data model. And the index service then tries to, or not just tries to, but it extracts all the necessary information that is necessary for filtering and for searching out of the data model and puts it into a so-called product index, which is then optimized for query performance and for filtering performance. So you define which attributes you want to have in your index. There are several search backends that are supported, like in simple MySQL table or Elasticsearch, or also external services like FactFinder or FinderLogic. And then we have a product list, which is actually the API that gets the indexed data out of the index again, and then allows you to list all the products in your product listings, for example. Once your cart is complete, you might want to start the checkout, and this is where the checkout manager comes into action. And the checkout manager is quite basic in the e-commerce framework. That's because checkouts are really individual, especially when it comes to B2B use cases, and therefore the checkout manager just creates a certain architecture, a certain framework for setting up checkouts, but doesn't provide you really a lot of functionality. One aspect of this architecture are the checkout steps, which are actually nothing more than information container for certain information that is collected during the checkout, like shipping address or the billing address, or some additional information that you might need to collect during your checkout. Once all the checkout steps are committed, then you can optionally start a payment by using a payment provider, where again the payment manager comes into action, which provides certain payment provider implementations and allows you to create payment transactions. And once also the payment is successfully finished, if it's even needed, then the commit order processor is started, which actually finishes the order, creates an Pimcore data object for the order, and also possibly adds additional functionality by sending the order to an ERP system or these kind of things. And then the order is finished and we have a final order data object. After the order is finished, then the order manager comes into play, where you have functionalities for order listings, for filtering for certain criterias based on orders or order items, and also have a so-called order agent, which is an API to work with an order after it's finished, like for refunds, like for canceling, and these kind of things, so where you can modify the order after it is finished. All these modules can be configured with the e-commerce framework configuration, which is actually a Symfony configuration tree, which allows you to configure all the different modules of the e-commerce framework. There you can specify the behavior of the existing implementations, or even specify that you want to use your custom implementations and therefore customize the whole behavior of the e-commerce framework. The factory is then responsible for instantiating the correct implementations for each of these modules, and also is responsible to consider the current tenant, which is necessary because the whole e-commerce framework and all the modules are tenant aware, which means that you can specify multi-tenant systems and can therefore configure things like shop in shops or different output channels for different e-commerce use cases. So you can set up really complex e-commerce applications with many different tenants. The next modules all have to do with pricing and price calculations. And there, the most important module is the so-called price system, which is responsible for calculating the prices for certain products. This calculation can be quite easy. For example, just calling a certain getter in your product data object, like for example, get price. But these price calculations can also be quite complex, like considering customer-specific prices, or even maybe calling remote pricing systems where you have certain web service calls for calculating the prices. And that's the reason why we have put this into a separate module, which is called the pricing system, and which takes care of all the price calculations. The price system itself actually just uses or calculates the list price. On top of this list price, you have the optional possibility to define so-called pricing rules within the Pimcore e-commerce application, where you can, for example, create marketing pricing rules, like for a certain period of time, for a certain product category, you give additional 10% discount, or have a fixed price or fixed discount. So there you have different conditions, different actions, and so you can modify the price that is calculated by the price system based on certain environment variables. Similar to the calculation of the prices, we have also the calculation of the availabilities, and there we have the availability systems, which again encapsulate all the calculation logic for certain availabilities, and each product knows which availability system it has, and actually asks then the availability system for calculating its availability. Now when we go back to our virtual e-commerce shop, we now have product listings, we have filters, we have of course all the product information which come out directly out of the product data objects, and we have price information and availability information. When we go to the product detail page, it isn't anything specific to the e-commerce framework. Product detail pages are actually standard Pimcore templates with standard routings, like for example Symfony routes or something like that, and then presenting all the available product information or all the necessary product information directly out of the data object, and using, of course, price systems and availability systems to visualize the pricing information and the availability information. But the actual detail page is standard Pimcore templating with templates with controller. There is nothing specific to the e-commerce framework itself. The next step, also in our virtual e-commerce shop, is putting certain products into a cart, and this is where the cart manager comes into action, which is responsible for all the functionality in combination with cart. So there is cart implementation, of course. We have two cart implementations with a session-based and with a data-based cart. Putting all the products into the cart. Then we have some cart price calculations where we sum up all the single prices of the products and get a subtotal price. And then we can add additional cart price modifications like shipping costs, like whatever additional price modification might be necessary. And after all the price modifications, we have a grand total, which is the actual cart price that needs to be used then for the checkout. Also on cart level, we have the possibility to add additional vouchers, which is where the voucher system comes into action. There we can define certain voucher series based on certain voucher tokens, which can be a single token or a pattern token, where we have certain voucher statistics, where we can see which voucher tokens were already used and how many of them, these kind of things. And in combination with the pricing manager, you can then specify certain discounts for certain vouchers, and you add these vouchers to a cart, and once a voucher is added to the cart, then all the voucher discounts come into action. The second module is the filter service, which is responsible for filtering products and helps you to create filtered navigations and layered navigations in your product listings. It has certain filter types like multi-select filter, like single select filter, like range filter, these kind of things, and creates all the necessary queries to the product listings depending on the filter type, and of course also depending on the search backend type, and so makes it much easier for you to create layered navigations and filters for your e-commerce application. Let's discuss how multi-language websites are set up with Pimcore. In Pimcore, each document has exactly one language. This language can be set up in the Navigation and Properties tab in the Language setting here. As a consequence, multi-language websites are set up with multiple trees. For each language, one document tree. This offers you great flexibility in terms of structure and content of each language. Of course, you can link documents for different languages with each other, and Pimcore offers you also some help when translating documents. One of which is the so-called content master, which allows you to inherit some content from one document to another. Let's have just a look how this can be set up. In this toolbar menu here with the translations, you can, for example, create a new document, choose the option Use Inheritance, specify the language. If already a parent is translated, Pimcore automatically finds the correct parent for your current document, and then you specify a tree and maybe a navigation name, and then Pimcore creates the corresponding document. Of course, on the correct place in the tree. And as you can see here, all the content is inherited from the content master document, which in this case is the English document. And then you can override the elements that are relevant for the translation, but all the other elements, like for example images and other stuff that doesn't need to be translated, you do not override and therefore inherit the content from the original document and follow the single source publishing. Actually, the content master document is not something that is limited to the translation functionality, but can be set up here in the SEO and settings tab of the Pimcore document. Below here, content master document, where you can set up any document which is the content master for a certain document. The option with the translation menu here is just a shortcut, if you like so, and offers you to pre-fill the content master document setting here. Once you have linked multiple documents for different languages, you have also, of course, this information here in this menu where you can quickly switch between different language documents and open up all the information. Database-wise, the object brick follow a similar approach as the field collections, with the big difference that, as we already saw, the object bricks support data inheritance, and therefore also we need to have all the store and query tables. And we already see it here. Pimcore adds additional database tables for each brick with the naming scheme object brick store, object brick name and class ID, and in addition to the store table we also have the query table. Difference between store table and query table is the same as for the data objects themselves. The store table is the place where the actual data is stored. The query table is the table for querying the data, having this query index, which of course has all the inherited data also stored within it. The tables themselves are again same as all the other tables, meaning that each attribute that you define in your object brick has a different database column here, and so it's possible to add all the different data and of course also query all the different data on a level of the database.